Hello and welcome to this video on let expressions in the Lambda Calculus, also known as let-in expressions. So, what does a let expression look like? It looks something like this. For example, let x equals 3 in odd x. Now what this is exactly saying is we have two parts here, a binding and an expression. And so x is bound to 3 in the expression. So in odd x, x is going to be 3. That's what our binding is doing. How do we evaluate this? It might be obvious already, but let's just go through an example. Here, very similar to function application, we're going to put that 3 into the expression odd x, where we're substituting x for 3, and we just get odd 3. Simple enough. You might look at let expressions and think, hey, that actually looks quite a lot like function abstraction and application, and in a way it is. So if we look at this function, this is kind of doing the same thing. Our body is odd x, and overall it's taking that x and binding it to something. In the bottom one we're applying 3, and so that 3 gets substituted in for x, and the top one we're binding 3 to x, and so it gets substituted in for x. You might actually say, well, isn't this less powerful than what we've had before? Because in the bottom one we can remove the 3, whereas in the top one, when we try and remove the 3, it's now incomplete and invalid. And in that sense it is, but what let expressions do allow us to do is something called polymorphism, where the same expression can have multiple types. For example, in this expression, we're saying let x equals the identity function in x odd x3. And here, it's interesting because we've got x is applied to 3, so we have an identity function for integers, and then odd converts that to a boolean, and then we have the identity function on booleans as well. And this will work for us in let bindings in Hindley-Milner. That's what we're going to use let-in bindings for. There's also other uses for them, but that's what we're going to do with them. But if you were to try and do that with function abstraction, for rules that I'm not going to get into now, we can't actually do that. When we try and derive the type of this function in Hindley-Milner, we're not able to come up with a consistent type that we can be happy with. So, we've seen this before. This is the grammar of the Lambda Calculus. This is how we define our expression, where we can say our expression is either a variable, application, or abstraction. We now want to add our let expressions to this grammar, so it's complete. They look something like this. So where we have let x equals some expression in the expression, which is the body. So E1 here is the value that x should take in the body expression, which is E2. So that's a brief introduction into let expressions in the Lambda Calculus. Hopefully that was helpful, and we'll see you in the next video.